When we use flexbox, sometimes it's magical and it just works and does what we want it to, and other times it doesn't quite do exactly what we ask. It starts doing some strange things, and it can be hard to understand exactly why. You start throwing some alignments or justifications on things to try and get things to behave the way you want them to, and that doesn't work exactly how you need, so maybe a grow here or a shrink there will do the job. Or what about a flex basis? But I mean, what is flex basis anyway? Well, in this video, I want to simplify flexbox as much as possible with some realistic situations that we can use it in to really understand what's happening, so then you can start using it with confidence. Hi there, my front-end friends, and welcome back to yet another video. I'm so glad that you've come to join me once again. And if you're new here, my name is Kevin, and here at my channel, I help you fall madly, deeply in love with CSS. And if I can't get you to fall in love with it, I'm hoping to at least help you be less frustrated with it. And flexbox is definitely one of those things that, while it's magical and I'm super happy we have it, it can be very frustrating at times when it starts doing some strange stuff. So in this video, we're going to be looking at how it works in some practical situations that you might run into on a regular basis. And we're going to break down why different things happen when we use flexbox and really understand the important parts of it. This is not going to be a full-on let's learn every single property and value possible in flexbox video. It's a let's learn the fundamentals of flexbox and the really important parts and how to think while we're using flexbox and the types of situations you'll run into most often with it, and really understanding the behaviors that are going on with it. So when you run into these situations, you have that control that you want and the understanding you need to write it with confidence. So we will be looking at a couple of different examples, but for this first one, we're going to be looking at a navigation, which is a very common and perfect place really to be using flexbox. And it's really going to help us understand a lot of the different aspects of it. And then we're going to jump into another example after this that goes into some other situations where you might use it. And in this example, I have some stuff on here to help visualize. So all of my code will be just up here on top of that because this is the really important part. And the first thing is I have my nav list here. And my nav list has these direct children, which you can see I've highlighted with different colors here, just so we can really understand and see what's happening. And so what we'll do is let's select that nav list first, nav list, and we're just going to throw a display of flex on there. And with that, they all just magically go next to one another, but of course the styling looks really ugly, so let's just do the typical thing we do on lists of a margin of 0, padding of 0, and a list style of none very quickly on there, just to get it to look a little bit nicer. And there we go, we get all of those items going next to one another. But we're here to understand what's happening with flexbox, and there's already some very important things that have happened that a lot of people take for granted when they're using flexbox. And so let's turn off my display flex for a second. And so we have these LIs here, and the LIs are block level elements. So they stack one on top of each other and they stretch to fill up the entire space with their width of auto. And as soon as I do a display of flex on here, what's actually happening is all the display block stuff just goes out the window. These are no longer display block. These items are actually now flex items, and they're behaving like a flex item. So if I actually came down on these and we select them, so we'll do my nav list LI, and I say this is a display of block, absolutely nothing will actually change over here. I could change this to inline, nothing will actually change there. Now if I did a display none, they would disappear. But if we try changing these types of things, inline block, same thing, that would have no impact on these LIs anymore, because these are no longer, these LIs, they're flex items, and they're going to behave like a flex item, which is one of the things we'll be talking about more in this video. So we're going to need to do some stuff on these LIs, so I'm going to delete this, but I'll leave this here for now, and we don't really need to see that. Let's focus on the CSS for now. And the other important thing that's happened right now is because they are flex items, what a flex item wants to do is it wants to be as small as it can possibly get to while maintaining everything on one line. There's a value which is with intrinsic sizing, so let's just do a width here of max content. And what this is doing, let's turn off my display flex, and now things actually look very similar. There's still block level elements, so they're still stacking in this case, but they've reached their max content, and so what this means is if there's text, put all of that text on one single line, you're not allowed to wrap, and that is now the width. You might be wondering, is there a min content? And there is a min content, which is going to choose, it's going to allow for wrapping, it's going to force wrapping, and it's going to use the longest single word within there, and then so that becomes the min content. And both the min content and max content have a role to play within flexbox, which is why I sort of wanted to look at that, but let's turn this back off. And so when we do our display of flex, it's going to that max content intrinsic size for these items, and it's shrinking them down to as small as they can possibly get without any line breaks. If it can fit that within the parent, and you can see here the parent is this big orange box, it can easily fit them all without any line breaks in that area, so it does just that. But if it runs out of room, it's allowed to create line breaks, as we can see here. So we have no line breaks, and then as soon as we run out of room, these will keep squishing and keep getting smaller and smaller and smaller until here where now we get some overflow because we hit this min content size that we have right there. So it tries, this is the ideal width. It goes, we want the items to be the size, this max content size, but if we don't have enough room in the parent, then we'll allow them to actually wrap their content inside of there. And as we're going to see in the second example, this actually gets really important. And the reason it's allowed to do that is because we have properties called flex shrink and flex grow, and those are properties that are over here on the child. And an interesting thing with Flexbox is the children have a lot of control over the different behaviors and the different things that are going on. The parent sort of sets the ground rules of how general, this is sort of how I want things to behave. And then the children are what really get a lot of the ultimate control in how the layout ends up working. And as I mentioned, we have a property called flex shrink. And the default for flex shrink is 1. And this is really what gives Flexbox its magic. And that's because if we didn't have flex shrink, let's turn it off. And we can turn it off just by throwing a 0 on there. And if we didn't turn off flex, or if we had flex shrink that was turned off, and we shrink this down, it's actually just going to immediately overflow. So the items are getting that intrinsic max content size, but that's the size they are, and they're not allowed to shrink from that point if we turn it off. And if this was the default in Flexbox, it would actually be very, very frustrating to use because we'd pretty much always be turning it on to get that behavior. Now, just to help space things out a little bit, I am going to come up here and add a gap. Gap is relatively new to Flexbox, but it just helps us add some space between things, which is super handy and super useful. So it just helps visualize things a bit more. And what I'm going to do next is, as mentioned, we have flex shrink, but there is another property called flex grow. And so let's throw that on there, flex grow. And the default for flex grow is actually 0, which means don't grow at all. And interestingly enough, as long as any of these is bigger than 0, it will be turned on. And it's a ratio in how things are growing and shrinking. I'm not going to get into that in this video because that's a little bit more advanced. And again, I want to keep Flexbox simple and just really understand the behaviors that you'll be seeing most of the time and not running through every possibility, even though playing with these ratios can be useful from time to time. So the default here is my flex grow of 0, but if we throw a grow on there, they're actually allowed to grow and get bigger. And to figure out what that space is, we'll put it back to 0. And within the parent, we have all this extra space that's left over on the side here. So as soon as I do a flex grow of 1, what it's doing is taking that leftover space and it's equally distributing it between each one of these LIs. As I mentioned, you can have different flex grows. As long as the ratio for all of them is the same, it would evenly distribute it. But if one of them had a different flex grow on it, then it would change that distribution. But we're not going to get into the nitty gritty, as I said. And so yeah, the flex grow allows, if there's space to grow, it's going to allow them to grow and fit that space. And because we also have a flex shrink on, that means if we have lots of room, they'll grow. And if they don't have a lot of room, they're allowed to shrink and they're allowed to squish down. But we, of course, run into this issue with having overflow when they can no longer squish down because they've hit that intrinsic min content size type of thing right there. And so there is one more thing that we can do, and this one is not on the child. This one is when we come back up to the parent. And I'm going to talk more about this parent-child relationship as we go. But we're going to set here a flex wrap of wrap. And what this means is items are allowed to also wrap and do some interesting things. So here they're allowed to grow so they can grow. Then when we get to the smaller size, at one point we get to this point and then they're going to run out of room. So there's two things that could happen. They could either continue to squish or they could wrap because I've turned wrap on. The default here is no wrap. And this is a bit of a weird one because it's one of the strange ones with CSS where there's no hyphen. And it just is what it is. But usually if you're declaring a flex wrap, you're just putting wrap because you're changing away from the default. And so then what happens is they're allowed to wrap. And notice here how it's wrapping. And they go and they wrap down like that. And they just do what they need to do. And these bottom ones are continuing to grow a lot. And you'll notice the growth behavior on each row is independent from any of the other rows. Because with Flexbox, each row is it looks at that row on its own. And they look at their own row of content, this is 2 columns, so I'll distribute that space evenly. This is 2 columns, but they're different, so I'll distribute that. Here, when they have 1 column, I'm allowed to grow, I'll fill up all the space. This is one of the areas where flexbox is different from grid, but we're not worrying about grid today. But then what happens is eventually the items no longer can wrap because there's just no more wrapping that can go on. And this big guy, he needs to keep shrinking. So he's allowed to shrink down, and then we can grow and shrink in that way. And you can sort of create a nice responsive type of thing here. Now, if it was a navigation, I would actually have flex grow off on this normally. I wouldn't bother with it. We wouldn't need the flex grow, but you might throw a flex wrap on there. So you don't need to worry about anything else. And then you have this navigation just with a display flex and just with a flex wrap, where each item is the size that it needs to be. And then as it shrinks down, they just wrap down and do their own thing. And this time, because we've turned off our flex grow, they're not growing and stretching across anything. They're just wrapping down, doing their own thing like they need to. And if they're too big for whatever reason, they just start squishing and smushing down. So when we declare a display of flex on a parent, the children become flex items, and it's only the direct children that become the flex items, and each one by default will create a column of content, and they all just go next to one another. And of course, that can be useful when you need columns on something as well. So here, let's go take a look at this. I have this div class of columns here, and then inside of there, I just have these 3 cards that we don't need this gradient shadow. This is from an old demo that I modified, and I forgot to take that class off. But there we go. We have a parent there with 3 different direct children in there. So as you might be able to guess, when we do our display of flex, it's going to create 3 columns and they go across. And let's throw a gap on here of 2 rem just so we can visualize and see a space between them. And this is one of those areas where people get frustrated with flexbox because they go, I want 3 columns, they do a display flex, and then they get 3 columns, but they're not what they thought because have you noticed they're not all the same size? So why is this happening? Why aren't all these columns the same size? And this comes back to what we were looking at in this example of that ideal size that it wants our items to be. And in this case, it wants all the items to be as long as they can be without any line breaks. And that's where flexbox always starts. It calculates that ideal size, and then if it needs to grow or shrink or do whatever it needs to do to get content to fit, it takes that ideal size as its starting point and figures it out from there. So if we look here, what I'm actually going to do is let's come and turn off my shrink. So we're going to say columns, and I can just select the direct children like this. I like doing this. So whatever is the direct child of my flex items, I can control however I want. So it's just selecting all of my direct children, which just happens to be these 3 articles. And let's throw a flex shrink of 0 on there to help us better understand what's happening. And so without the shrink, again, we're going on based on the longest line of content. So that's the paragraph that was here is pretty much defining the size of each one of these. But this last one has a lot bigger of a size because it had a bigger paragraph or a longer paragraph. There was more words in there. So it's stretching that out across that single line. First, flexbox is calculating how big each one would be without the shrink on it. And then it's coming in and it's adding that shrink in. So what flexbox is saying is, I want all of these to be their ideal width. And just to help visualize what's actually happening here, let's come and add a border here. We'll do a border of 10 pixels solid. We'll do fire brick. And you can see that this is actually stopping here because it's wrapped in a container that's holding its max size. But just, let's just say width 800 pixels just to really clear things up. And, we've locked in a size, it's there. And so when we do our display of flex here, it's going all the direct children are now flex items, and then it calculates these ideal widths. But now flexbox looks at it and goes, well, I don't want them shooting out the side like this. They don't actually fit. So with that default value of flex shrink, it's shrinking them all down. And the important thing with both flex grow and flex shrink is that they're ratios of growth and shrinking. They're not fixed numbers. And because it's a ratio of how much it should shrink by, if something is smaller in its ideal width, it's going to still be smaller once we get to its shrunk size. Those ratios are still going to be maintained even though it's shrinking or growing, and it's not trying to make even columns. And actually, if you'd like to go further into the math and how all of this is calculated, I'll put a link to a video down below, or I'll put a card up here, it should be popping up, that goes into this behavior in more detail and actually shows the math behind all of it and how it's really calculated. But again, I want to keep things simple for now. And I just realized this says flexbox versus grid, and flexbox made simple because I forgot to update it from that last demo that I mentioned that I was working on. So yeah, they shrink at the same ratio. Now, one way And of course, sometimes you want these to actually be equal columns. And so one common solution you'll find online is putting a flex 1. And when we do that, you can see that they all balance out and become equal. But why is this happening? This is a really, really important thing to understand with flexbox because it's really fundamental in the different things that are going on, and for you to be able to, like, if you want to use flexbox with confidence, knowing what this is doing is so, so important. And this flex shorthand actually accepts 3 different values because it's a shorthand for 3 different things. But if you but it allows you to omit the other ones. And so what it's actually doing when you say flex 1 is the first thing it's doing, the first value is always your flex grow. So it's setting the flex grow to 1. It also has a flex shrink on here, and it's just leaving that alone. It's not changing it. But one thing that it is changing is the flex basis. And the default flex basis is actually auto. And if I put that back to auto, you can see we go back to that problem that we were having. And when we omit the flex basis from the flex shorthand here, for whatever reason, the spec says that this auto should actually be turned into a 0. And then by putting that to 0, they all become the same thing. And that's kind of weird, right? That, like, why would flex basis 0 actually do this? So I'm just going to delete this, and we'll stick with the longhand for now. And let's turn off my flex grow and put a 0 on there. We're going to turn off our flex shrink and put that to a 0 as well. So we know that these aren't doing anything, and our flex basis is actually controlling everything. And so we'll put this back to an auto. And the auto, as you would assume, is just letting things behave the way we saw from the beginning, because that is the default value for flex basis. Now, if I came in and I said flex basis 300 pixels, and we'll see that it's actually setting them all to 300 pixels. And you can think of flex basis a lot like width. It is different from width, but it's very, very similar, and often thinking of them in the same way is the easiest way to really understand what's happening. Now, that gets thrown on its head a little bit with your flex direction as well, and we're going to talk about the axis, the main axis versus the cross axis as well, and that's where flex basis sort of comes in. But most of the time, even when you're doing that, you won't see the flex basis have a big impact because of how we're usually using flex basis, because you're normally not setting something like 300 pixels on it. But yeah, in this case, it's setting the width to all of them to 300. They're not allowed to grow, they're not allowed to shrink, so they're all sitting at a width of roughly 300 pixels. And what's interesting with this is if I set the flex basis to 0 pixels, you'll notice they don't actually become 0 pixels. And this is one of the differences between width and flex basis, because if I came on here and I say these have a width of 0 pixels, they will actually go down to 0 pixels widths, and we just have a bit of padding that is left over on them. By default also, with the flex basis, like if I put this back to auto, they're going to look exactly the same right now, just because the auto value here is going to look at the width anyway. So if you're putting one or the other, just setting a width or setting a width on top of the flex basis, this will have a big impact. So usually you're using one or the other and not both of them. But yeah, the width 0 will actually make them 0 pixels. And again, it's the padding that's showing up there. Whereas a flex basis of 0 won't actually go to 0. It's going to go to as small as it can. It's that min content intrinsic size again, because flexbox tries to make sure things continue to work and they don't break along the way, like setting a width of 0 might do. The reason that flex 1 often works is because when you have that flex basis here of 0, and again with flex grow, when we have leftover space, it's going to equally distribute that space into each one of the flex items. So when we do a flex basis of 0 and a flex grow of 1, things will grow to fit that available space. And of course we want to keep the shrink on there just to make sure that shrinking is allowed. And then of course we will turn off this width because it's not very responsive right now. And then we get this type of thing. And again, this is the equivalent to just writing a flex 1, which can be a very nice solution in getting something like this to work. Now, another way that I often do it, and you'll see in my own videos, is actually just setting a width of 100%. I just find it a little bit easier, and you could also do this as a flex basis of 100%. And again, flex basis width, when you're keeping things simple and you're not going into edge cases, you can think of them as very, very similar properties. And if you really want, pause the video now and see if you can figure out why this is actually creating equal columns, and see if this understanding of flexbox is starting to sink in. So the reason for it is the default value is a flex shrink of 1. And if we did a flex shrink of 0, this flex basis of 100%, or if it was a width of 100%, means each item wants to be 100% of its parent. So they're all growing and they're all becoming 100% of the parent, which means they all have the same width. So then when the flex, that default value of a flex shrink being on gets turned on, because they're starting all at the same size, they're all shrinking by the same rate, they all end up being the same size. Now this can get thrown off a little bit if like two of your items have padding and one doesn't have padding, or if the padding is different because of how the algorithm works and it's really based on the content size, not including your padding. But if all the items are the same, you should end up with equal columns with either one of these, doing a flex basis or width of 100%, or of course using flex 1 like we saw as well. We're going to go from this example here, and then we're going to jump back to the other example with flex direction to really understand what's happening. And so when we have a flex direction, and one way that we can set things up with this, and this is one of the reasons actually I like using flex direction rather than a media query to declare a display of flex, is what we'll see in just a second here. And so here with my display flex, we can change my flex direction. And the default flex direction is a row. And this is kind of weird because we have row, but we have columns here. But remember, we're looking at the parent right now. So we're saying that the parent is a row, and that means the main axis is the row axis, so the horizontal axis. And this main axis, and we're going to see your cross axis come up. If you're learning about Flexbox, you've definitely seen these talked about. The main axis is always looking based on this flex direction here. So the flex direction is row, so it means it's going from left to right or horizontal. And so this is our main axis, and then up and down becomes our cross axis. And we're gonna see why this matters when we go back to the other example after. So we have row, but we can switch that to column, like that. And when we have a flex direction of column, that means each one of the children is becoming a row. So we've switched the main axis. Now the main axis is on the column and or vertical, up and down. And then the cross axis is now the horizontal one. So we flipped the way that Flexbox is working. Instead of working across, the main way it's working is now up and down, so the items stack inside. Now, the reason I like doing this is, say we want 3 columns, but at a small screen size, we want them to be stacked like this. And then what we can do is have a media query at media. We'll say a min width of, we'll just say 600 pixels for this example. It's just a random number that will work for the demo I'm building. And in here, we'll say my columns has a flex direction of row. Whoops, we'll do row. There we go. Got to spell things right for it to work. And that means when a screen gets bigger than that, it becomes a row. So the flex direction changes, the main axis switches, and then we get these columns coming in. Maybe we'll boost this just to a little bit bigger. Something like that. So here we're at the small size, it's fine. And then we get to this bigger size and it works really well. And the reason I like doing it this way, switching my flex direction, instead of just adding flex here, is if I took this off, this display flex, those spaces disappear. And so then I would need margins. And then when you're having to go, okay, they need a margin bottom at this size, but then we have to turn that margin bottom off and add it in a different way somewhere else, it just becomes really annoying. Whereas the nice thing with Flexbox now working with Gap, and this is in all modern browsers, browser support is not perfect, but if you're only worried about modern browsers, then this should work perfectly fine. Then you can see here that it works both ways regardless, and it just always works. And that's just like, when they added Gap to Flexbox, it made me so happy, if this for nothing else, because this is just so wonderful not to have to worry about changing how the spacing on things is working. And so I really like that. But let's go back to here to really understand the cross axis and the main axis a little bit more. And to do that, we're going to start by working on the main axis. So here we can turn off my flex wrap for now because I'm not going to be using it. And we're going to come back down to these children over here. When we're working, we're going to start with our main axis. And when we're working on the main axis, we're working on justify content. And justify content will always be your main axis. So if you change your flex direction, it's going to switch with it. We're only going to focus for now on working on it just in this horizontal mode like this. So in the default one, which is the flex direction of row. And the only time justify content will actually work is if there's leftover space. So I'll show an example of something that I've seen come up for people where it's not working and why sometimes justify content doesn't work. But let's just start by doing the easy one, which is center. And that means take the content and center it within the parent. So let's just turn that off really quickly. And it's just like when we were dealing with flex grow. FlexGrow would look at all the available leftover space and distribute it equally. So when we use justify content, it's looking at the leftover available space within the parent, and then it's going to, in this case, equally distribute it on both sides to center the items. We also have other things called flex start, which is the default. It just leaves it all the way on the left. Or we have a flex end, which is going to do the opposite and push it all the way to the other side, the end of the main axis versus the start of the main axis. They are actually working on getting rid of flex and just letting us use end, and this is something you can do in CSS Grid, but we're not there yet. This isn't really supported very widely, but it's on the way just to have end and start, which will be very nice to have. So we have flex end, flex start, and then we get the really interesting ones, which are dealing with the spacing. So one of them is space between. And when we do a space between, once again, what it's going to do is it's going to look at the leftover available space that we have, and it's going to take that space and equally distribute it between each one of my items and space everything out. Another one that we have is space around. And space around is not the most useful one because what it does is it puts an equal amount of space on both sides of each item, but it does mean that the space here and here actually looks, or it is less than the space between our items. Every now and then I have a use case for this, but it's very, very rare. Those were the first two that we started with, but because of these problems that people didn't like how the spacing was working, doubling up or being half, I guess, on the outsides, they added space evenly. And space evenly just means put equal space everywhere, which it just becomes a lot more practical. And this is a lot more useful of one. Yeah, so that's justify content, and justify content works along the main axis. And the issue that I've seen come up when people are using justify content, there's two. One of them is that, the screen is small, and so there's nothing to really justify because, remember, it's taking the available leftover space on the main axis and it's distributing it. But if these items are shrinking, that means that there is no space left to distribute, so nothing will actually happen. Another situation that's very, very similar where there's no leftover space is if you do have a flex grow on something, that grow is going to grow first. So they're growing, they're taking up all that available space, and so justify content has nothing to work with and it doesn't actually do anything. So if I did this as then a center, well, they already are centered. So there's, right? Like there's no available space. So as far as flexbox is concerned, it is already centered. Or if you need space around, there's no space to distribute around. So you just have to make sure that the parent actually has leftover space that it's going to be distributing. So you just have to make sure that the parent actually has that leftover space that it's available to be distributed for your justify content to work. And another time I see issues come up is when the flex direction is changed. So flex direction of a column, and I still mix these up. So if you mix up row and column and you don't get the right one, just know there's only two to choose from. So you try one, it doesn't work, you switch it to the other one. Hopefully that does what you want it to do. I mix them up all the time still, and I use this all the time. So I did my column here, and then I did a justify content center, and now my justify content should be working vertically rather than horizontally because we switched my main axis. So now we're working up and down, but it's not doing anything. But once again, if we look at the box I have on my parent, there's not actually any space for items to be distributed along because there's no leftover space. And that's where you'd actually, for justify content to do something, you'd be setting a height here. So you might, it's a nav, maybe you're doing a mobile nav where you have a VH of 100 on it and it's sort of overlaid over everything else. And then you can come in and actually use this justify content and do a center or a space between or whatever it is. And then we get the space between each one of them. Let's just drop this down to 50 just for this demo. And yeah, now we can distribute that space because if we didn't have any justify content, they're all here and there is that leftover space here on the bottom. And basically because of how items work, where the height of a parent is usually defined by the children inside of it, if you do want to use justify content in a vertical way because you've changed your flex direction, you basically always have to give the parent a height. And a lot of the time, if you are giving something a height, do give it a min height, not an actual height. But yeah, let's get rid of that. We'll get rid of this. And we'll just do a justify content space between to leave this demo off at. And so when we jump back to here, let's come and take a look. And what we'll do now is we're going to look at align items in this example because alignment of items is on my cross axis, and the cross axis means my vertical axis in this case because I haven't changed my flex direction. And it usually comes into play when you have some items like this that are longer than other items like these two. So this one is bigger, so we can see that they're actually all the same height, but that's because the default align items for flexbox is stretch. And because it's stretched, they're all filling and they're all fitting the same size. But let's switch this over to a flex start, and then they squish up like that. And so when it's flex start, they're going to their intrinsic size as if they were block level elements for their heights, where the height is matching the content inside of them. Then we have a flex end, which, as you might guess at this point, pushes them all the way down to the bottom. And then, of course, a center. And people complain about vertical centering being hard in CSS, but look how easy that is. So easy to do. And again, this is only working because this item has more content in it than these two items here. If that wasn't the case and these all had equal heights, there'd be no space to be distributing around here or playing around with. So there would just be nothing that would actually be going on. But because one of them is bigger, it gives us this room to play with. And to, if you need to center something vertically, becomes very easy to do. Now, unlike justify content, we don't have things like space between or space evenly because they're working on the cross axis, which doesn't have other items on it. There's only one item on the main axis. So space evenly wouldn't really make any sense because there's nothing up and down here to space evenly with. Whereas when we go left to right on the main axis, and the main axis always has multiple items, which is why we have an align items is individual, like each individual items alignment, and then justify content because we're dealing with like the whole block of content that's moving around. We do have an align content, but that involves flex wrap coming into it. And most of the time you won't be running into a situation. I'm not saying it doesn't exist and you won't run into it ever, but it's more of a fringe case compared to your align items. Your 95% of the time will be using justify content or align items. And just like your flex direction, where you might mix up your row and your column, with align items or justify content, you're going to mix them up and you're going to forget which one does which way. You try one, if it doesn't work, you try the other one and you're perfectly fine. Now, one thing that's cool with align items also is you can do individual alignment on like single items. Justify content, you can't do that. You can't do a justify like self. It doesn't work just because, again, we're dealing with a block of content with other things around it. Whereas with alignment, we're dealing with a single item and how it's aligning within a space that it has available to it. And so to do that, we could choose one of these items in here. So let's just come to here and we're going to say that my, it's just a card. So we'll say card nth child of 2. So we're going to select our middle one. Let's change the background on here so we can see it. Background is pink. And it should change the color. There we go. And so we've now selected just this one. And so I can choose an align item of flex start, and it's going to overwrite that parent's control that it had, and it's going to do its own thing where it should, align self. I did item, we want self, and it's going to move up to the top. And I was like, why is this not working for a second there? So we're saying on my own, do my own thing. Don't listen to what everyone else is doing. I'm different from my siblings, and I'm going to ignore my parent and sort of do what I want to do. And you have all the same properties: flex start, flex end, center, or of course a stretch here. And you might be wondering, can I do this with justify self? Is that justify self doesn't exist for that reason we were sort of talking about before, where the we'll put this to a flex start, where it doesn't, the justify self wouldn't work because the justify self's really, justify content is dealing with many items, whereas an align items is looking at each individual one along the cross axis. So justify self works within grid, and you might see it come up with grid because you're dealing with how it's aligning within the cell that grid is defining. We don't have that within flexbox, so there's no justify self. There's other ways to overcome that though, but I don't want to get into that because it's more edge casey than what we're covering in this video. And if you enjoyed this video and you'd like to go deeper into Flexbox, I do have some videos linked down below, but also I have a cheat sheet that has all of these properties and values that we've been covering throughout this video. So if you'd like to get that cheat sheet, the link is just down below for quick reference on how to align things and move things around. It's just a PDF that will hopefully help you out. And with that, I'd like to give a really big thank you to Johnny, Adam, Stuart, Randy, and Tim, who are my supporters of Awesome over on Patreon, as well as all my other patrons for their monthly support. And of course, until next time, don't forget to make your corner of the internet just a little bit more awesome.